Hello and welcome to today's webinar, Optimizing Your Cloud Native Databases, presented in partnership with SolarWinds and produced by Actual Tech Media. Thank you so much for joining us on this webinar. We've got a great event lined up for you with a live demo. It's going to be a lot of fun. Before we get started, just a few things that you should know about the event. My name is David Davis of Actual Tech Media, and I'll be serving as the moderator on the webinar today. Like we said, we want this to be educational, so we encourage your questions there in the questions tab. Of course, we appreciate all the hello and good afternoon messages from across the United States and around the world, but we also want to help you to solve your challenges in the world of IT, specifically around cloud native databases. We'll be doing a dedicated Q&A session at the end of the webinar, so get your questions in early. We also have our best question prize that we're doing this year. It's an Amazon $50 gift card that we award to the best question on the webinar. We also have a number of handouts in the handouts tab that you should be aware of. Check out the couple of PDF resources there, one on ensuring successful Azure SQL database cloud migrations, and another on managing the multiple database journey. It's great to download those resources now, and that way you can check them out after the webinar. And then finally, at the very end of the presentation today, I will be announcing the winner of our Amazon $300 gift card. You must be present on the live event, and the prize terms and conditions can be found there in the handouts tab. And with that, I'm excited now to introduce you to our expert presenters. Welcome, Mr. Nick Kaminsky, Sales Engineer at SolarWinds, and Mr. Jared Hensel, Senior Product Marketing Manager, also at SolarWinds. Nick and Jared, it's great to have you on the event today. Thanks for being here.
Thank you, David. All right.
Well, take it away, Jared.
All right. Thank you. All right. So what we're talking about is optimizing your cloud native databases. Real quick, a little bit about myself is, I'm came from a technology background where I was dealing with systems, databases, virtualization, and everywhere in between. But now at the SolarWinds, I was responsible for their system side of the house, and now I switched over to the database performance management side of the house. Unfortunately, I forgot to add Nick's bio slide in there. So Nick, why don't you tell me a little bit about yourself?
Great. Thanks, Jared. Nice to meet everybody today. I am a sales engineer here at SolarWinds. I've been here a little over a year and was at Vivid Cortex previously. Have been working with database performance and data analysis, my whole career, and love to bring that knowledge to helping clients really solve their biggest problems, especially as they, do things like migrate to the cloud and adopt these new technologies. So excited to be here today.
Awesome. Thank you. So I've got an agenda within an agenda. So this is basically what we're going to kind of talk about is optimizing your cloud native databases, do a brief overview of the SolarWinds solutions, briefly talk about DPM in particular. That's the product that Nick will be demoing. We'll kind of go over some use cases beyond just the cloud native databases. And then Nick will do a demo. Again, as David said, please feel free to ask your questions. We'll get to those at the end. If somehow I see one that totally is pertinent right to the moment, I'll kind of jump in and try to answer that live as we go along. With that said, as organizations are increasingly deploying cloud native databases, you need to stop and still figure out how to monitor them, how to make them run better, anything along those lines. I mean, Gartner came out with a stat saying that 68% of the data DBMS market, growth is going to be in the cloud. But again, you can have very similar, if not the same performance issues in the cloud that you do on premises. So again, the cloud definitely will solve some of your problems, but it will not solve every one of your problems. So what we're going to do is talk about, some cloud native databases in this demo, Azure SQL, Amazon Aurora, MySQL and GCP. Again, as people are going to these cloud native databases and are shifting from your traditional on-premises databases, you still need to optimize and tune them. Some of the things you'll pick up and learn is, why you need to monitor them, why it's more important. Obviously, paying that monthly bill or your, yearly bill to your cloud provider will definitely give you a reason to tune and optimize them. Some common challenges, different things that you may have to step back and think about, hey, this is how I thought about it on premises. This is how I have to think about it in cloud. While databases are relatively similar, what you can control, what you have visibility into may differ. It may differ from Amazon to AWS to GCP versus an on-premises solution. And then really how our solution, obviously DPM, is going to help you tune those and ensure that you can deliver a good database, which obviously is hopefully, mission critical to your company's success. A little bit about SolarWinds as a whole. Obviously, this is a riff on Gartner's ITOM chart, where we basically have everything from app to database to infrastructure. Who are we servicing? IT ops, DevOps, security, anybody in between. Again, we're going to focus on the database performance management slice of this. But again, SolarWinds as a whole has multiple solutions that help you either go from on-premises to the cloud. Once you're on the cloud, you can have an APM solution that integrates, that we're working with, things along those lines that really help you, deliver world-class IT. Some of the, honestly, we try to be more connected to our customers than anybody else out there. Rely on reviews and surveys and awards that, hey, we're getting ranked by customers, because sometimes we don't always do what Gartner says. Hey, this is what our customers say we need to do, not what a Gartner person says what we need to do. So with that said, I'm just going to start talking directly about the product, Database Performance Monitor. As Nick alluded to, it was an acquisition formerly known as Vivid Cortex. It is a separate SaaS-based application compared to the traditional SolarWinds stuff that was on premises. So again, this is a separate build process, a separate infrastructure than everything else we have. What does it do? Obviously, we've got traditional open source and cloud native databases. So again, we've got Azure SQL, MySQL, Postgres, Mongo, Aurora, Redis. And so you can see that we've got those databases, but then we've got them in different cloud vendors. It's not just, hey, all I do is support everything in AWS and nothing beyond that. And again, those databases, they don't have to be cloud. They can be physical boxes back on premises. Obviously, we're focusing today's webcast on the cloud side of the house, but physical, virtual, or cloud, it's irrelevant to us. We can get that data and start letting you optimize and tune it and finagle it. So how does DPM work? We're providing a holistic view of your open source databases, for your entire team at scale. So again, there's no point in, hey, I do all this monitoring, but I completely kill the database itself. And when I get to 10, I'm completely slow. We've got customers with tens or thousands of databases that we're able to pull in. So again, as your company grows, as your database deployments grow, we can scale out there. Again, you're able to see these all in single dashboards. You can create custom dashboards. So again, you're not having to have different tools. You're not having to log into like the OEM solution for this vendor or that vendor. You can have one solution and then tailor it towards your needs. You can have certain views that just show you, hey, I'm just looking at MySQL or Postgres or Amazon or whatever it may be. You've got the ability to customize it that way, or I just want to see everything in its whole entirety. You can see full visibility into the database workload and the query behavior. You can get into infrastructure level on premises. You can pull in cloud statistics for AWS. So again, you can get into those environmental data as well as the internals of the database to see cause and effect, anything along those lines, and really optimize and see where your problem is. And then with 1 second granularity, you're able to get out in front of small issues. You're not looking at, okay, I've got a 10-minute here, I've got 5-minute polling, and it then summarizes at 10 minutes, anything along those lines. Because, in today's world of e-commerce, SaaS solutions, you need to look down to that level of detail. If you're just sitting there and taking your 15-minute average, you're going to miss small problems that are going to have a cascading effect. So again, getting to that type of granularity, Especially if you're deploying code or doing an application update, you want to know what exactly happens right now, not, okay, yeah, I need to know in 15 minutes what's going on. So that level of detail of what's going on. So again, it's a SaaS solution. It is separate from all the other SolarWinds products. It's hosted in its own data center, everything along those lines. So again, as you're moving to the cloud, you want something native, it's there for you. It can pull in the database health, including the internals. Some of the features are before and after comparisons. Obviously, that is very code centric, where, hey, I'm deploying code. I want to see something now. I want to see something an hour ago and compare them to. I can look at my query analysis, see what's going on in real time. I can go back and look over time. I can, say, hey, I can see this. This is the growth over the last month or last day, or hey, here are my trends, or hey, this didn't exist and now it exists. What's going on? Obviously, any solution you want to have your automated alerting. So again, you can come in there and put custom thresholds and hey, kick out an email, connect to ServiceNow, whatever PagerDuty, whatever you want it to do. As I alluded to with the dashboards before, you can focus on the set of databases you're responsible for, the set of systems, whatever it is, you can customize it to East Coast, West Coast, whatever variant you want. You're able to tune it to meet that need. Be it I monitor all the databases. I've got one database, anything along those lines. And then we are GDPR and SOC 2 compliant since it is a SaaS-based solution. Some of the use cases that our customers typically are using is obviously the code. I want to see changes in behavior, related to new queries, identify outliers, get recommendations. So you may be running this in a dev environment. Hopefully you are, as well as production, to go, hey, I'm testing things out in dev, in test before I push production. So I want to see what this is doing to the system. So when we go to production, I can anticipate this is normal, this is not normal, this is expected, unexpected, and compare it to what you're trying to achieve. If somebody's writing code that is designed to lower CPU usage or decrease query count or reduce latency, push it out there and then look at it. Did it meet that? Yes, no, maybe, and then determine, hey, we need to go back to the drawing board, or yes, this is ready for prime time. And then in production, it's IT. Inevitably, there are going to be issues. You're going to have something squirrely happen. It's not a matter of if, it's a matter of when. So again, how quickly can you zoom into that issue? How quickly can you, fix the issue? Can you see it? Is it something that's just one server, one instance, or is this something globally? And again, optimizing. Hey, I've got it out there, but I constantly need to be, how can I make this better? What steps do I need to take? Is there a recommendation? Is there something I missed to make this better? You should constantly be striving to optimize your workload. Just because it's running, now doesn't mean it's going to run tomorrow. How can I make it run better tomorrow? And then just overall database health. Hey, I need to pull this in. I'm not necessarily a DBA or a developer. I'm just an IT generalist, and I just need some indication of what is my database is doing as a whole thing. Am I seeing any kind of outliers? Is something funky going on? Are we constantly seeing spikes every Tuesday at 10 a.m. that I can start trying to correlate, cause and effect to, or is this truly a one-time outlier? It's only happened once, we're fine, or hey, this is frequently happening. So this anomaly, while still anomalous, is on a pattern. We need to dig in deeper. And then sharing it across multiple teams. You may just be a small IT team that everybody's in there, or you could be a very large organization. So you've got different dashboards, different alerts. Again, customizing the tool to your need, because again, we don't want you to have a tool that you sit there and, okay, hey, it works for 2 people and the other people it doesn't. We want everybody to be in that single platform to honestly optimize, monitor, and triage database performance. With that said, I'm going to kick it over to Nick for a demo.
Great. Thanks, Jared. I am sharing out my screen here. So let me know if you have any trouble seeing the
We
demo
got it.
environment. Perfect. Great. So I'll go ahead and kind of start things off to continue on the last slide that we were just talking about. I appreciate really taking out the time to learn more about DPM today. And we'll kind of focus on the proactive, reactive, and general health and baseline visibility use cases that we were just talking about. But I do want to take a step back and just kind of quickly go over when previously Vivid Cortex, now SolarWinds DPM, started. The main goal really was to give that visibility and the ability to monitor more proactively the systems that were switching over from the legacy databases more to the Web 2.0 technologies. And then we started to see the shift towards the adoption of cloud technologies with managed services and all of that. So we have always been on the cutting edge of trying to give that visibility into the systems that, whether it be self-managed, cloud-hosted, cloud-managed, across the board, to give that visibility to end engineers who might need the visibility into those systems but aren't necessarily DBAs themselves. So our whole goal has always been to empower the full engineering team to take accountability of not only the functionality but the performance of the queries they write and the database operations that they might be in charge of. So a great way of kind of summing that up is the summary page here, where we can quickly see that, we're integrating our CloudWatch metrics from AWS CloudWatch for those 13 hosts in this demo environment here. We have a combination of different monitored technologies across all of the different database types that we support across cloud-hosted and self-hosted offerings. So this demo environment here is a combination of everything, but it really highlights the cloud-specific functionality that we have. And from the summary page here, any engineer can come in and see the kind of high-level status indicator of their system, the end user health and experience from kind of these key health metrics, and then also look at the top resources and how they're changing over time, and then dive into recommendations to actually check where the DPM processes are essentially pointing to inefficiencies in the system and potential for optimization there. So from this page, we get a rich breadth of data, but now we want to dig into the depth of looking into specific systems or really understanding how the heavy hitters are driving this behavior. So we have the profile.
I was going to say, one thing I liked on that last screen was that set of metrics also mimics Google's golden signals. So, if you're using an APM and that thing, these things sort of line up and tie together when you're thinking about how a database ultimately serves an application. And so having some sort of common, I guess as Google said, they're golden signals for success or, stability or performance. It is nice that they kind of jive that way.
Yeah, that's a great point. That actually was the key goal behind the summary page as we've continued to build on it, is to have that approach of the key golden signals of health, but show you the same time series across all metrics that are important to look at. So great. That's a great point. And actually, before we switch over to the profiler, I think it's also good to mention that DPM is meant to handle whether you have one database instance that's incredibly important to monitor and you need that full visibility, or whether you need to monitor a full data center that's 100 mission critical servers and you want to bring everything all into one place. We try to handle that workload regardless of the volume by the filtering in place. So if I were to, let's say, take advantage of our advanced syntax to apply my own tag and group servers together, we actually have a very simple guestbook application that's running on an RDS, MySQL RDS, and MySQL community server. So this equates to 2 hosts. And if I were to apply that filter, we would see that the behavior on this page shows information specific to those instances where we're focused more on the top activity there. And then if I jump over to another page, this filtering stays. And so the actual workload that we see in the actual metric data is going to mirror the host and time filter here. So if you're doing a deep dive into an individual system across a complicated data center, it's really easy to pinpoint the specific systems that you want to put underneath the microscope. Or I can take that filter away by a simple click And now I'm looking at my aggregate system health across all my monitored technologies. Additionally, the time filter is going to dictate and govern the metric data that we see in every view. So it's easy to really specify, let's say I want to look back in time, or I want to understand how a change I made in the last hour is affecting the query workload or potentially causing changes. The profiler is typically where we find our clients will go to rank, sort, and filter top activity and triage and resolve change. So here we have the ability to rank based on a variety of categories. And I don't want to spend too much time diving into one, but you can see that we can look at multiple dimensions of database performance and then rank across several dimensions based on the category that we're looking at to really understand what's driving the behavior we see in the system and what could be the potential cause of bottlenecks or degradations in the query workload, or according to one specific user's activity, for instance. So we can really get granular into looking at specifics about how the database is performing from this simple view here. Now, additionally, we can rank and sort and filter according to those dimensions, which will give us this time series here, as well as this percentage, but we can use the sorting from the additional columns to focus on other behaviors. So if I want to, for instance, look at my most time-consuming queries to understand what's driving the top of my workload, but then maybe look at other dimensions and see aspects of that query's performance that might be driving a degradation or the cause of a spiky performance profile versus a more standard or kind of uniform profile of how that query is executing, I can simply layer on these additional columns and then use this matrix view here to specify, is it, maybe these high frequency queries that an APM solution or manual checks don't catch because they're not slow running, but they're enough of the workload that, we need to especially focus on them and maybe use a caching layer or do something to reduce this count because of the impact on the system. Or, for instance, we can focus on the slow running queries and really see what might be driving this high latency. And are these statements, are they potentially performing poorly, or is it just a matter of, we know this is a big impact on the system and we need to make sure it's tuned and ready for the amount of, workload that it's going to require just to run this. So when we find that there are statements also of interest from this view, we see that there are these errors and kind of warning red boxes here. What we can do is quickly dig into problematic queries by looking at these errors, warnings, and failed query rules, which is data we're able to capture essentially at runtime. So when we look into an individual statement, this is where DPM really goes to shine, is you can quickly look at how a query is executing across multiple different servers and what the breakdown looks like there. I can also investigate samples of the query over the execution time, and I can drill into the additional metrics and analytic data that we're able to get at a really, really deep granular level to understand exactly how this query is performing and where I might want to do something like add an index, because we see that the majority of the times that this query is running, it's running without an index. So we're able to really surface these poorly identifying queries, which gives us the visibility into the key goal of the database, which is to run queries. And what we find with our cloud native customers is typically they don't have this visibility, and it's really hard for them to get this visibility. So we try to put as much detail in this view as possible. And the point of DPM really is to give this granular approach, but also to capture a comprehensive set of data. So we do rely on sampling for the actual really deep granular sample capture, but we are capturing 100% of the execution statistics. We're able to really capture the full profile and capture this level of data for all statements run against the database, rather than relying on only sampling the most frequently run or slowest queries and only focusing on those. We're able to give a full picture of the workload. And then for these poorly performing queries that you might otherwise not have the visibility into, we can focus on a sample, for instance, and get this great data. So as a team operating at scale, it's great to be able to send your whole engineering team into DPM with our unlimited user model and very quickly find insight into how is this query being run, where is it being run from, is there potentially a problem with how the query is written that DPM is able to surface and show us what we could potentially do to improve that behavior, as well as what does the explain plan look like, because very quickly I can see we're performing a sequential scan, and I can even drill into the exact cost of every single operation. So with this data, I'm able to quickly make decisions, or if I have too much on my plate, let's say I'm a DBA and I just want to point folks who are responsible for tuning these queries at the right place, I can easily share with the short link feature here and freeze the time range and say, hey, I noticed that at this point in time, this query was pulling the absolute worst plan possible. Let's make sure that we tune this and then evaluate, what the new plan looks like, and then validate the fact that, we are performing this query in an optimal manner. And you can easily send that to the rest of the team rather than have the bottleneck be at the DBA or DevOps engineer level where they're required to do all of the tuning and put out the fires. So I do kind of want to take a step back and focus on the fact that this is really where a lot of our customers find the value in being able to bring the whole team in, point every developer at the queries they're responsible for, and get really deep detail into the actual performance of every individual statement without needing to learn a lot about database operations and optimization. We try to point them the right direction, and then from there it's usually a slam dunk on actually making the changes and using the data that's given to make those improvements to the system.
Yeah, Nick, I was going to say, I liked how when you came in here, it was that, on the profiler screen, you quickly said, like, is it a death by 1,000 cuts, or is it just a few that are long running? And again, like, I think there's a misconception that, hey, I put my, database in the cloud, or I build it net new, that these problems don't exist. And that's the farthest thing from it. I mean, can you mask some of these things with cloud resources and memory? Sure. But if something's executing 1 million times on premises and you move it to the cloud, that number's not going to change, So, having that visibility really kind of highlights, hey, and again, you're paying for this monthly or, whatever your agreement with your cloud provider, but using that to really jump into those screens starts the gears turning on, hey, my executive, we went to the cloud, we've got this cloud initiative, and we're going to have all this ROI and all this uptime and all this. And you may go there and it still may just run as poorly as before, or, even if you're building it net new, just because of poor design. Exactly.
Yeah. And honestly, to piggyback on that same point, another great feature of the query detail page here is what we typically find is a lot of customers in the cloud who have those same concerns. They are they're using replica sets or a microservice model, for instance, and they're not running everything on one monolith that might be running multiple database instances. They're running across a really distributed infrastructure set. So what's great too is with the query detail page, not only can we find out the impact of the poorly performing queries, but I can also get an idea of how this query is executing across different infrastructure. And so a great point to illustrate this with this statement, for example, is we see that across the 4 servers that are running this query, or that ran this query over the last hour, we see that only about just over 10% of the total execution count is attributable to staging 1, which is a Postgres server. Now, if I jump back to the total time distribution, I can quickly see that this climbs to just over 55% of total time, which is simply a product of count by average latency. So we see that there's very clearly a bottleneck running this query against this server, which might have a different resource profile in terms of CPU memory and other system level resources thrown at it. And so it might be a case where this query is only performing poorly relative to one server, and that server needs to be tuned. So you can quickly make those calls using this granular detail without needing to dig into the history of all your infrastructure and system metrics over the last couple months and start to try and make decisions. Where that's also illustrated too is our Explorer view. And I'm going to jump over there really quickly. This is essentially where we can take that profiler data and pull that into one view. So essentially what that looks like here is all of these data sets from the profiler, I can then chart on this dashboard here, where the y-axis is going to be the unit that we're currently measuring. So in this case, total time. And so I can look at my top 30 queries by total time across the same y-axis here and see, okay, let's say we want to investigate the impact of these spiky statements, or even let's say we want to take them away and look at what the general profile of the query behavior looks like. We see that for the most part, the average response time is less than 10 seconds in aggregate for all of our top statements, but then you throw in these insert statements that seem to have a pileup in their execution, and we see now we're on the order of closer to an hour of aggregate total time. And so if I have concerns that this might be impacting CPU or disk or memory and potentially bogging down the infrastructure that's actually powering this database instance, I can quickly build a diagnostic dashboard here and look across the different utilization metrics to really understand, is this hurting me in terms of CPU? Should I expect end customers have a slowdown here? Is this a resource that, we commonly see, let's say, the cache miss ratio is, constantly hitting high. We can, throw the necessary resources at that dimension and then line up over the same time series how that metric changes relative to the query workload. And so for the folks who are usually not used to this level of visibility, this is especially helpful because we're able to pull in your infrastructure, system status, and query level data sets all in one place and help you make those correlations without, spending too much time running checks. So this is especially helpful for those the cloud native customers, because I don't know if you noticed, but when I type CloudWatch, we're able to integrate all of those CloudWatch level metrics. Same for Google Cloud Stack Driver. So we're able to pull in the instance level resource utilization metrics and give you that full picture into how things are performing and how changes cause kind of the ripple effect throughout the whole system. So
that's great, because I mean, as dynamic and awesome going to the cloud is, I mean, anybody can slide a lever over or just say, hey, I'm going to change the instance size or increase that. But truly, without actually having insight to, did that actually fix a problem, or even having insight, yes, it made it better 10%, but I doubled, my bill, whatever it is, you can now make some educated choices as an IT team, as a DBA, a developer on, hey, that's not this, throwing more CPU at it is only going to take us so far, or adding more hosts is only going to take us so far. Hey, look, we did that. We added a host, and guess what? We for twice the price, we saw 5 times the improvement. I don't know, something's crazy. But again, having that data allows you to make the educated decisions. You're not just blindly sliding toggles and assuming the database is just going to be awesome, and that's not going to affect your bill in any way.
Exactly. Yeah, and we've actually seen the tangible effects where a lot of customers have been able to right-size their infrastructure and make sure that when they do capacity planning, that they're actually taking into account a workload that makes sense for how they plan those resources and the hardware spend in the future. And for a lot of the cloud native services, for like Aurora, for instance, we find that customers are able to bring down their spend through controlling IO costs and additional costs that come with the cloud licensing and pricing model that they might have overlooked. For instance, creating temporary disk tables can be incredibly expensive for customers on MySQL Aurora. So we're able to help you get that full picture and kind of leverage the data in the best way possible for your team to make those decisions, and understand that if you pull one lever and you expect there to be a response that might pull multiple other levers, you can then validate the impact of those changes. So that's really the goal of the Explorer here. Now, we also know that some organizations, given this data, it's great and they find the visibility is especially helpful, but sometimes they need a point in the right direction. And so on the proactive side of things, we have our best practices. And this is really great because it helps customers take the insight from the metric data that's readily available. We apply some additional insight analysis and processes in place to map a whole series of best practice checks against your environment. And where that's especially helpful, we found for the cloud native folks, is when we look at these query rule recommendations, and I'll go ahead and focus on the Postgres query rules here, but you can see that when I click the dropdown here and expose the multiple recommendations, I can also see that there are multiple occurrences for this recommendation. So in this case, we can use this as kind of a static analysis dashboard to look at every single statement that might benefit from improvement, but might otherwise not be on our radar because we aren't looking at the dimensions that these checks are exposing. So for the folks who might be using an ORM or other ways of kind of building these queries, but not actually doing the performance testing, we're able to expose some of the potential bottlenecks and degradations that can happen as these database systems scale out over time. And as these queries are pulling more and more data, we're able to map a really robust series of different checks, whether it be for individual statements and how they process data, the actual syntax and the data operations underlying that, or when it comes to the actual configuration and how the system is tuned itself. So we're able to get some really, really good insight into what you could do to improve this behavior. And then the end user can choose to either mute or take this insight into mind and make these changes. And as these changes are made, we'll go ahead and pass them over time. So as we see, some of these rules start to gray out because we've made these improvements and those are tracked by the agent. So we can treat this as a moving dashboard in terms of pointing to where we need to make those improvements. So this is really helpful for kind of pointing to the queries where they might not show up in the profiler as those top heavy hitters, but we could still benefit a lot from improving them and making sure the system is as tuned as possible. On the flip side too, I know that some organizations sometimes have a really, really large query data set where the heavy hitters, might be well past the top 50, and they simply just need an ability to search in and find queries, and potentially also find queries that might be problematic due to specific behavior. So that's why we have the queries page. Now this is essentially a flat list of everything executing over the time frame set by the time filter, and all of the queries executed across every server set by the time filter or by the host filter. So I can choose to ignore those and then search based on the specific syntax to find a statement. I can also use this to track when new queries were first introduced in the system. So if I apply that, I can say, I want to look at everything that's new over the last hour and see if there's potential room for improvement here. Or I can look at queries that might be flagging specific problematic behavior. So every query that was run with an error, for instance. Or I can look at things like slow response time and missing indexes to put certain behavior underneath the microscope and really look out through the whole environment. So I know a lot of cloud native customers sometimes have issues with visibility, even past those top statements. And what we try to do is give you that full picture into everything that's running, even if it isn't necessarily the heaviest hitter in the system. And then on kind of the last side of the baseline analysis and profiling the system, we have the notebook feature, which is great. Our customers leverage this quite a bit. And I'm going to jump into the Postgres RDS health check, which should have been loaded. And what this is, the way that this is valuable, specific and unique from all of the other pages, is this is a custom report written in Markdown where I'm able to leverage this, standardized way of formatting this report. And when I actually look at the report itself, I can use custom filters and specify unique systems underneath the microscope, and then look at metric data across different dimensions, add my own text-based analysis, and then do additional kind of dashboard creation here where I can look at the health of the system across all these dimensions and create an executive report that I can then send to somebody else. And at DPM, we have a lot of people on staff who have extensive backgrounds with database optimization and database performance management. So we constantly have them contributing these great health checks and different ways to report on aggregate system behavior. So as time goes on, we've continued to add these checks to these health checks to the customer environments. And so this is something that you can leverage to look at how to report on, your system's performance at the executive level, if need be. So this is really great for kind of digging into what you could do to improve the system and then reporting on that for the non-power users of the group. So with all of that, that's kind of the full picture of how we use DPM to investigate proactively, reactively, and look at the baseline health. Now, the last piece before I kind of want to wrap things up and open up for questions is we also find it very important and valuable to integrate with additional tool sets. So we find that most cloud native customers and customers using SaaS also use other SaaS tools for alerting, incident resolution, issue tracking. And what we've tried to do is build out a pretty robust set of integrations where you set up the integration and you can ship alerts to your team in Slack or VictorOps, PagerDuty, as well as set up a custom webhook for the non-supported options. And then what that actually looks like when we create an alert is we can alert on the event and threshold-based data in the system. So by default, the agent will capture all kinds of events automatically related to database performance. You can also leverage the API to send custom events like an app deployment. So I'll use that as an example. And then what we can do in this view is take the historical data of that event over the last day, week, month, and help you pinpoint how to set this alert and specify whether it be a unique server that we only want to trigger this alert when we see a specific event happen across one server or the whole data center, as well as on the flip side, we have this threshold-based alerting where I can, for instance, just type MySQL, and it helps me fill out the metric as I go. But if I were to say queries, for instance, then it would pull up one unique metric that's being captured and show me the history. And I can also do the same analysis and then set the threshold based on the actual value of that metric. So this helps me really tune the reporting and alerting and how I keep track of this system, where I'm not necessarily in the trenches looking at the data, but I want to keep an eye when, something hits the fan and I just need to know kind of exactly what's affected and where I need to look. I can set these alerts to be kind of my proactive ears and eyes to keep me tuned into when when something happens in the system and I'm not actively looking at the metric data. So with all of that, Jared, I don't know if there was anything else you necessarily wanted to add while we have the demo environment up here, but that is kind of the full picture of what DPM can do for cloud native databases.
No. We've got a whole bunch of questions coming in, and I'll let David MC those. But we may end up going back to the demo environment, so don't
Sure.
Don't close anything out. But yeah, we'll kick it back over to David to continue on the conversation.
Awesome.
Absolutely. Yeah, great demo, Nick. Really appreciate that. Really cool what you can do with DPM. So we've got a lot of great questions coming in. I want to remind everyone of our best question prize we're running today. So get your questions in early. I've just brought up the poll question for everyone out there. You should see that on your screen. Would you like DPM pricing information or to schedule a product demo with a SolarWinds engineer? Get your own personal demo, ask all the questions you want. I'll leave that poll question up for you to reply to or respond to while we start answering these questions that have come in. So first question I see on the list, Douglas is asking, when it comes to utilizing DPM, how do you handle or test interoperability with different programs based in the cloud? And then second part, what testing do you provide to assist with this to ensure maximum functionality?
Nick, why don't I let you answer that one? Because you're on the phone with customers a lot more than I am.
Yeah, so I guess what we try to do is when it comes to integrating data from something like CloudWatch or Google Cloud Stack Driver, what we've done is integrated directly with the API, and we're pulling data from the API just as an organization would manually. But we've had our engineering team go through and test all of those, what data are we capturing? What are we missing? Where are the gaps? And we essentially just go through and test everything on our own, on our side. But we do things like use Vivid Cortex or now DPM to actually monitor our own infrastructure. So we know that if a customer were to encounter a certain gap or a certain hurdle with adopting to a certain platform or a certain solution, we usually experience it first because we've had to overcome that hurdle ourselves. I hope that answers the question.
Excellent. Yeah, great answer. Next question, they say that they are to use SolarWinds NPM to monitor their DPM offer in addition to NPM.
So I think your audio cut out there, but I see, what does DPM offer more in addition to NPM and Nagios? And that's a great question. We actually have a lot of folks who are using Nagios come over to DPM because they find that having the additional advisors and best practice advice, and then the ability to kind of take the insight and analysis from the feature set that we have. So the compare time range analysis and the additionally being able to use the diagnostic views and different features like the Explorer are ways that customers find it's easier to make correlations with this query caused this CPU spike and created this problem for this specific host. It's really the correlating and tying together how a problem in the system actually affected those resources and what you can do to improve that.
All right. Excellent. That. Next question from Ned. He says, for successful database migration from on-premises to the cloud, how does SolarWinds gather the right performance metrics for benchmarks, budgeting, and tracking costs going forward?
Yeah, Jared, do you have a good go-to for that, or should I go ahead and take that one?
You can take that one.
Gotcha. So as far as I know, at least on the DPM team, what we try to do is we talk to our customers a lot, and we actually have dedicated customer success engineers who meet routinely with every customer, and we get an idea of what are the actual benchmarks and metrics that we should be looking for, and how is this seen by your organization? Because we can only answer so many questions by handling our own problems or having our own, testing in place. But we really rely on our customers in the industry and listen as much as possible to answer those questions. And then actually also, Jared can probably throw a plug in here. We have the SolarWinds Thwack forum is great because we constantly have employees here as well as customers contribute there. And that's where we can kind of have that one source of true knowledge as to what everybody sees. If that makes sense.
Yeah, no, I mean, and what you're talking about, I mean, DPM is highly, like, our customer success, like you said, really want to make sure you're tracking what you need to be tracking. And again, we've seen a lot of people, DPM may not, I don't want to say may not be the right tool, but ultimately you may be wanting to monitor the application. The database is behind the scenes. So your ultimate guide to success is how is the app responding? And a byproduct of that is database performance. But again, some of these metrics translate. Again, if you are looking at, like you said, a count or latency or anything like that, that is a metric that if you're moving it to the cloud, you should have a reason for it. You're trying to drive the latency down. The count may stay the same, and hey, my success is I'm on old gear on premises, and I need to go to the cloud. Either I'm buying stuff from Dell or HP, or I'm or spinning up a new VM. Obviously there's no accounting model in this, but again, I think there is some, off the side stuff that you just basically look at cost and try to evaluate, hey, this is going to save me this much money, and here's my metric that I'm going to use for success against it.
Yeah, that's a great point.
All right, excellent answers. Another question, this one's from Nicole, who says, with this Explorer view, can it be modified to user access needs, such as can multiple users have that access, and can we limit what view certain users see?
Yeah, it's a great question. So we do have role-based access in place for, with DPM, there's 2 licensing tiers. There's standard and premium. And with the premium tier, you do have role-based access control to where you can specify and administrate access to certain users to see certain data.
And don't forget, you want your executive dashboard that's just a green circle, and that's all they can see on the web page. It's just green, and that's what No, I mean, yeah, like you said, the role-based control, or even if you just want knock screens, like you said, is just create some of those charts and share the URL so that they can just splash it up on a knock screen, something along those lines too.
Nice. And then another question came in. David's asking if you have any recommendations at an index or even field type level.
Yeah, it's a great question. We hear it quite a bit. Right now, we have not been able to build the index advisors into the best practices because of just the complicated nature of what it takes to recommend an index. Because, like I said earlier, you pull one lever and occasionally 3 then move. So what we typically do to answer those questions is the customer success engineer there is one who is assigned to every new customer, and they'll work closely with looking at the table and database collection data, which we are able to track, and then they can help make those improvements. But we don't natively have any index advisors as it stands, because of the complexity of what it would take to provide those. But that is a great question, and we do hear it at least once a week. So.
Excellent. And again, I want to remind everyone about the poll that's on the screen there. In fact, we have a question regarding the demo. If someone requests a scheduled personal demo, can you kind of tell us a little bit about that? Like, how long does that typically take?
Yeah, so that it really depends on who we're talking to and the key goal of the conversation. I've gone on a call and been able to go through kind of a 10-minute overview of the key features we just looked at. But I'd say on average we are right around about 20 minutes, and that's the kind of best middle ground for being comprehensive but concise. And so that's kind of the sweet spot.
And I will
Excellent.
add too is that, obviously you've got those demos. I cannot tell you how much better a demo is if you're running if you're actually running it. Obviously, there are demos like Nick just did where we're using our data, our test data. But truly to get it up and running in your environment and then see your data, I know it makes a world of difference. The questions you're going to ask are different of like, I'm seeing this. What does this mean? It just makes more sense when you're like in the car than just trying to shop via the internet. Truly taking it for a test drive, you're going to see buttons you didn't see before or see corks or anything like that. So, again, that's I don't want to say an easier way. I mean, obviously your demo will be much more customized at that point because it is your data. And I think your conversations will be more in depth at that point too.
Yeah, also I'll actually pull back up my screen share just briefly. I know we're close to the end, but the install process, if the question is related to if I were to do a demo evaluation for the cloud hosted databases, you'd follow our auth host, and then I'll just pick MySQL as an example. And as you see, there are a few steps here at the top, but it really comes down to you set the credentials and point to where the agent will be installed to monitor where the monitor server is located. You would check to make sure you would create a user with the necessary privileges for monitoring. You would check that the database diagnostic schemas that we rely on for metric capture are configured correctly. So performance schema for the sake of MySQL, but everything is documented in the in-app wizard. So when you start an evaluation, you'll be able to see this yourself. And then you would install the agent on its own compatible server, which is Linux or FreeBSD based. And then from there, we would just run a quick check and you're done essentially. So for the actual installation process, it's about could be a 5-10 minute process to get set up and started.
Excellent. Yeah, thanks for sharing that. I'm sure that helps a lot when it comes to visualizing exactly how this would work and how it's deployed. I'm afraid we're running out of time here, though, in our scheduled webinar event today. Before we go, I just, again, want to remind everyone about the poll, and I'll leave that up while we announce our Amazon $300 gift card winner on the event today. That is going out to Catherine Maroney from California. Congratulations. We'll reach out to deliver that gift card. Thank you, everyone, for all the excellent questions. We're going to have to get back to many of these after the event that we didn't have time for. But Nick and Jared, really excellent presentation. I love the live demo. Thank you so much.
Thank you for having us.
Yep. Thanks, everyone. Hope you have a great afternoon.
And thank you to SolarWinds for supporting the event. Again, check out the 2 handouts that are available for download there in the handouts tab. I hope that you learned a lot and have a great day. We'll see you next time. Bye-bye.